Here I am, students, fresh off the tennis courts. I don't think you guys realize, but doing this flipped classroom thing is giving me homework to do every night. So it's kind of hard for me sometimes to get a video. It takes a couple hours to put these things together. And of course, you sit and watch for 25 or 30 minutes. I know the last one was kind of long, but it keeps me hopping too. I have to get off the tennis court, come right over, do a video. This video is about chapter 15, and it's on page 410 in your textbook. There's some important differentiations you've got to make over the course of this chapter. Really important distinctions that will help you succeed on your big exams at the end of the year. For instance, there's a difference between brown smog and gray smog, and you need to know the scientific terms for those things and understand what the causes are. The causes are different in each case. The second half of this chapter, after the air pollution part, is all about the ozone problem. Now remember, ozone in the stratosphere is good, and that's the ozone that's been damaged by CFCs. Has nothing to do with climate change. It has everything to do with too many UV rays getting through to us, causing cataracts, skin cancers, and things along those lines. So we're going to go through the different classes and categories of air pollutants, some of the acceptable numbers for air pollutants that are allowed to be in our atmosphere. And you need to remember that ozone in the troposphere, you remember the different layers of the atmosphere? I hope you do. Troposphere is the air that we breathe. Ozone at this level, at the air that we breathe, is a pollutant. It's very bad for us. Ozone in the stratosphere is good for us. All right, well, let's get started and take a look at the PowerPoints I've put together for this chapter. You talk about how long it takes to do this. I just finished the entire lecture and realized that I didn't have the recorder on. Ugh. How am I going to remember all the stuff I just said? Okay, this is a picture of Chattanooga, Tennessee. We've talked about the success story of Chattanooga in terms of how it's cleaned up its city, both its river and also now we see it's a poster child for how to clean up the air. This chapter, beginning on page 410, is all about air pollution. Human-caused air pollution and naturally occurring air pollution. The second half of the chapter is about ozone depletion, and we're going to keep that completely separate. The most important things for you guys to remember is that there are very specific linkages I want you to make between the pollutant and what it causes and its source. We can get started just by looking at this picture of Chattanooga. One of the problems that we have with air pollution is that whatever gets up into the air, if it doesn't get pushed out by the jet stream, it lingers over the city. And many of the cities that have air quality issues because of this. Notice how Chattanooga seems to sit in a bowl. It's got mountains all around it. And because Chattanooga sits in a bowl, these mountains kind of block the airflow, and so whatever comes out of these cars, whatever comes out of the factories, smokestacks, etc., whatever comes out ends up in the air here, but it stays and it hovers. Air pollution is more problematic than water pollution because if you don't live near the river that's polluted, it's not bothering you all that much unless it contaminates your drinking water. But with air pollution, it bothers everybody that lives in and around the area. And truly, air could be considered a common. Because these pollutants don't just bother you here, but what if we do get these chemicals up into the air and they blow on? Well, there's another city over here somewhere that's going to get your pollution. And that becomes a problem when we learn about acid deposition. So, air pollution and air quality in our cities, and indeed in cities around the world, are dependent upon lots of people, which means lots of cars and lots of manufacturing and lots of smokestacks, lots of electricity. It means topography. The layout of the city matters in terms of its air quality. If you're a city that's kind of sitting down in a bowl, you're going to have worse air quality. And the third thing is, are you a place that gets lots of sunshine, lots of sunlight? See, I grew up in Binghamton, New York area, little town called Endicott, and that was in a valley where there were 3 rivers and mountains all around. But there wasn't a whole lot of people, and even if there was a whole lot of people, there was never a whole lot of sunshine. I mean, I think we were in the Guinness Book one time for having the most non-sunny days in a year. So without that sunshine, even bad topography and too many freaking people doesn't add up to having real air quality problems. I'll give you another example. Look at Miami. Does it have 2 of those 3 things? You betcha. Lots of people, lots of cars, oh yeah. Lots of manufacturing, lots of sunshine, you bet. It has all those things, but it's not in a bowl. And you don't hear very much about air quality problems in Miami. Do you hear much about air quality problems in LA? Absolutely. Because they have that 4th problem, topography. They have a big mountain range. Picture the map of the United States. They have a big mountain range right through the middle of their state. And so when the ocean breezes come from left to right, the air of LA gets stopped by those mountains and hovers and forms something we call smog. All right, well, let's get into these different chemicals. Again, I want you to remember something about every one of them. Let's start with sulfur. Sulfur dioxide. I want you to remember sulfur, and I want you to remember sulfur in terms of smokestacks, burning coal, and other things that come out of a manufacturing plant. Sulfur dioxide. Nitrogen dioxides, they come out of smokestacks too, but I don't want you to remember nitrogen for that. I want you to remember nitrogen for cars. And you'll see why the next video. When you think of carbon oxides, you should think of any incomplete combustion. Whether it's wood, coal, oil, natural gas. All of these things release carbon monoxide and carbon dioxide. Now these are 2 very different problems for us humans. Carbon monoxide is very dangerous for us because our hemoglobin in a red blood cell cannot tell CO from O2. So if you breathe in carbon monoxide, your red blood cells will snag it and carry it out to the rest of your body thinking it's oxygen. You won't know this is happening until you get oxygen deprived, which means basically you get lightheaded, woozy, you pass out, and you fall out right in place where the carbon monoxide is, you die. Carbon monoxide poisoning happens in about 30 minutes. Carbon dioxide is not harmful to humans. You're probably breathing it in right now. You exhale it. So when you take in your next breath, some of what you just exhaled goes back in your lungs. It's not an irritant. The big problem with carbon dioxide is simple. It's a greenhouse gas. So the CO2 issue is about the environment. The CO issue is about human health. Particulate matter. You'll see it called PMs. Know that acronym. PMs. Particulate matter is tiny little dots. Tiny little particles. Anytime you see smoke, guess what? There's tiny little particles in there. and you can kick these particles up. Dust is particulate matter. You don't believe you breathe in particulate matter in a house? Remember that old story I told you. If you sometimes when you're near a window in your home and you're in just the right angle, you can see the sunbeam come through the window and you can see little dust particles. That is in the air everywhere. And your lungs have to handle that somehow. Well, if you're adding larger particulates, like dust from a dirt road, it can be real damaging to people's lungs. Photochemical oxidants. The word photo is key for you here. These are chemicals that oxidize in sunlight. And we'll talk more about that when we talk about smog. Ozone. Remember the old thing. Ozone in the stratosphere is good. Ozone in the stratosphere protects us from the sun's UV rays and protects us from skin cancer, cataracts, things like that. Ozone in the troposphere, the air that we breathe here, is bad. Now, not a lot of things release ozone into the air, but ozone forms with a chemical reaction that occurs between O2 and O, making O3. So ozone is a lung irritant. Ozone is damaging to our lungs when you breathe it in. Down here at this level, it's pollution. Up in the stratosphere, it's good. We've talked about lead with water. We've talked about mercury with water. Both of these, think the burning of coal. Now, we've done a pretty good job of decreasing the amounts of lead and decreasing the amounts of mercury that come out of smokestacks out of coal burning power plant, but they're still out there. And then the last major pollutant, VOCs. You will see that acronym on your exam. VOCs, volatile organic compounds. And VOCs come primarily from solvents, paints, gasoline, that put out fumes. Volatile organic compounds, think of fumes. And any kind of a substance or compound that tells you to only use it in a well-ventilated area is putting out VOCs. So it can be a problem if you're in an enclosed space. For instance, and you're painting. Not a good idea. If you're painting a closet or something like that, you've got to be very careful about breathing in those paint fumes. That is VOCs. I got to tell you, if you just memorize this table, which is in your book on page 412, if you just memorize this table, you'll have half the chapter figured out. Half the chapter will be figured out. The other half, of course, is the hole in the ozone layer. Because you'll know all of the different air pollutants, and you'll know their major source, and then you'll know what their impact is. I've kind of given you a thumbnail sketch of these different things. And that's the way I want you to remember them. So when you go through your process of memorizing, sulfur, think coal, think smokestacks. Nitrogen oxides, you need to think cars. And carbon monoxide, you need to think cars. Now, it's incomplete combustion of any kind. So when you burn wood in a fireplace, some carbon monoxide is released. But unless you're in a tiny enclosed room, it's not going to bother you. That carbon monoxide is in the air around you. And of course, most of it goes up the chimney anyway. All right, this diagram here is in your book on page 413. It just shows you how we measure PMs. Remember that there are natural causes of particulate matter. It's not just all human activities. Anytime you see smoke, there's particles in it. In a volcanic eruption, obviously, there's ash. Ash can be very, very large particle like this one. The smoke that comes from a wood-burning fireplace, that ash is relatively smaller. but also the dust particles that kick up when you drive a car. Ooh, hey, look, it's a Mini Cooper. I'm gonna have to tell my wife about that. You know, she drives a Mini. She loves that little thing. But you can see the different micrometers, the different micrometer levels that are used to measure particulate materials. And these are lung irritants. You know, if a car goes by you on a dirt road and you get caught up in that smoke, you'll cough, and your tiny little hairs in your trachea will catch that. You might cough it up. The hairs in your nose will catch that. But what if you're exposed to it for a sustained period of time? Like, for instance, if you're in a mining operation, or if you live in a developing country where they're starting to develop lots of cars but they don't have paved roads yet. Particulate matter, PMs, can be a problem. Here is your very important first definitional distinction. We distinguish between primary pollutants and secondary pollutants. Of course, primary means first. So let's talk about them first. Primary pollutants are chemicals that are released directly into the air. It doesn't have to be human caused. It can be natural. This is a mining operation, so there's lots of dust particles. That's PMs going up there. But all of these things, smokestacks in factories, your house, cars, are all releasing things up into the atmosphere. And these are the chemicals that are being released. Now, they are bad enough. All right, carbon dioxide, greenhouse gas. Carbon monoxide causes asphyxiation. Volatile organic compounds. You remember what VOC stands for? Good. Sulfur dioxide smells. Nitrogen, don't forget, think of cars whenever you think of nitrogen oxide. So these things are bad enough, but let's make matters worse. Because there's water vapor in the air, these chemicals will, once they're up in the atmosphere and get into a cloud situation, they will get together with the water vapor and form what's called secondary pollutants. SO2 plus H2O yields. Let's circle that and go right to H2SO4 sulfuric acid. So these primary pollutants get into the air. They have their own issues, but when they react with water vapor, form acids. H2SO4. Same with nitric acid here. These chemicals are produced in the atmosphere. That's why they're called secondary. Nobody is pumping sulfuric acid into the air, but they are pumping SO2 that reacts with water vapor to form it. Ozone in the atmosphere. Nobody's pumping ozone into the air, but with a nice sunny day, O2 and then some monoatomic oxygen is always in the air that we breathe. We end up with O3 with the catalyst of the sunlight helping that occur. So ozone is created secondarily. Got it? Primary pollutants are the things that come out of the smokestacks and the tailpipes. Secondary are formed while the primaries are up there. Alright, we don't need to talk much about this. Volcanoes put sulfur into the air. They put carbon oxides into the air because it's burning. They put sulfur, and of course they put PMs. Lightning is a big contributor of nitrogen oxides into the air. Forest fires put carbon monoxide, carbon dioxide, and PMs into the air. These are all natural sources of air pollution. So I guess the point is that our air can have issues even if there were no humans on the planet. But guess what? There are. And that's where we come up with, once again, everybody remembers the definition of this word, right? Anthropogenic, human caused. And what are our sources of air pollution? Simple. Cars, power plants, factories, And you all remember what we talked about when we discussed fossil fuels? Waste disposal like methane. Ever smell the rotten egg smell? Sometimes that comes from a landfill. That's hydrogen sulfide. So waste disposal. These are all things that add significant nasty chemicals, those ones that are on that table, into the air. All caused, of course, by us. This graphic here is a great way for you to see the main culprits of 4 major pollutants. Carbon monoxide, you should be thinking cars. And I'll tell you some carbon monoxide stories. Sad to say, but I mean, when I was growing up as a kid, a couple would die, a couple of high school teenagers would die just about every year from carbon monoxide poisoning. And I'll tell you why later on. Nitrogen oxides. What did I tell you to remember about nitrogen? One thing, cars. I don't care that you remember about any of these other things. Is it true that nitrogen oxides are released when we make electricity, when we burn coal? Absolutely. But I want you to remember cars. And there's a reason for that you'll learn in the next video. Sulfur dioxide, think smokestacks. Fossil fuel combustion at power plants, industrial, and electricity. Yep. By far the big culprits when it comes to sulfur dioxide. And when it comes to particulate matter, you can see lots of different culprits. Road dust is bad. We get this a lot when there's development in an area. It's damaging to your lungs. You need to wear some sort of a mask or something to trap the particulates and keep them from getting into your lungs. In fact, if you were to put a white mask on and go out, this has happened to me. I've put a white mask on and gone out in my backyard and driven my riding lawnmower just to chop up leaves and stuff. I have a section of my property that has no grass, and it kicks up dust and dirt and all that stuff. And I get done after about a half an hour, take the mask off, and you look at it, and there's a big old brown spot right where my mouth was. And that shows you I inhaled, and that brown spot was all of the tiny little PMs that got trapped. Anyway, it should not be hard for you to remember that PMs, particulate matter, are road dust, and wherever there's smoke comes out of a smokestack, that smoke has particulate matter. And of course, when we have a bonfire or something like that, you see particles come out. You can see some of them sometimes. All right, getting to the end of this particular chapter. Let me see here. As a matter of fact, this is the last slide right here, and it is just showing you trends in the United States when it comes to our ability to get below the air quality standards. And we haven't changed very much since the 90s, have we? This graph begins at 1990, and you can see it is on a downward trend, but not much. Lead is the best at coming down, and that shouldn't surprise you as we continue to outlaw lead in products and so forth, and as we continue to get rid of gasolines that have lead in them. Remember, this is in the United States. We see a downward trend in the amount of lead. But the amount of ozone production, remember, ozone is not a primary pollutant. It's a secondary pollutant. So there's not much we can do about what happens in the air. It stayed pretty flat. PM's down slightly. So the question gets to be, what can we do to get more of a downward trend in these chemicals? And we'll talk about that in the next video. Okay, I think I'm done. This is the second time I've been through this, and I'll bet you'll be happy to know I did this in way shorter of a time than the first time. All right, let me get this thing on YouTube, and I'll talk to you later. Bye-bye.